Morning, afternoon. It's morning where I'm at, and I have no idea what you guys' schedule is like. If you do like the normal thing and like get up and get schoolwork done and then do something else, or you do something else and then you cram it all in at the end of the day. I kind of think it's probably more number two for a couple of you. I want to remind you that I'm available from 9 to 3 if you want to Google chat. I guess it's Google Hangout video about math help. Some of you need some math help, so please use what's available to you. I'm having a math chat today at 1 with the other Algebra 2 students, and then I want to meet with you with BRMS and JH on Thursday. I guess you have to let me know if you want to and when you're available, as I'm available. Somebody's paying for me to do that for you. So let's talk. Righty then. Lesson 67, finding inverse trig functions. You're going to want your unit circle today. For sure, for sure. In fact, if you don't have it out in front of you, pause and get it out before we go on any further. Oh, look at it. Look at the date. Promise no tricks today. I hate that kind of stuff. Happy birthday, Busy Right. Okie dokie. We're gonna play a couple little games, and you're gonna need your unit circle for this. Just really quickly, let me remind you that if we take the point 1, 0 and we rotate it around the unit circle, theta degrees, either in radians or in degrees, wherever we stop, the address for that point is now cosine theta, sine theta. Make sure you're in the right format or the right mode on your calculator if you want to do it that way. Remember that for a lot of the problems, we've been doing things in degrees, but I want you to be thinking more in terms of radians. And looks like that's what the book set in today. So I'm going to switch my mode to radian mode, and we're going to be using the pi button sum as well. Okay, so let me ask you some questions, and you can use your unit circle to find the answers because you probably don't have it memorized yet. I am going to be doing the first round here in degrees. So what I want you to do is I want you to find the angle, and then I want you to find the right part of the address. The x part of the address is the cosine for that angle, and the sine, the y part of the address is the sine for that angle. So I'm going to write them down, and then we'll let them sit there. What's cosine of 45 degrees? What's the sine of 135 degrees? Cosine of 60 degrees? Or the sine of 90 degrees? I want you to give me the value, okay? So you got to do two things there. One, you got to go find that angle, and then you go up to the edge of the circle. It's not the edge of the circle, whatever, it's the circle itself. And then you got to use the right part of the address. Remember that the first part, the x is cosine, and the second part, y is sine. Okay, now you probably should write this down on a piece of paper as you're taking notes. That you're writing the answers in. So first one, I go to 45 degrees, and I go and I say the first part of the address is root 2 over 2. That's the value for cosine at 45 degrees. Then sine, 135 degrees is over here. And I'm asking for sine, and that is square root of 2 over 2. I go to 60 degrees, and I want the cosine. That's the first address. That's 1/2. And I go to 90 degrees, and I pick out the sine. Sine is the second value. It's 1. So if you didn't get those, then you need to figure out how to read this thing. Okay, that's usually the game that we play, is analyzing an angle for the cosine or the sine. And, you know, if we were doing this with 30, 60, 90s or 45, 45, 90 triangles, we're constructing the triangle and then looking at the sides and comparing them. We don't have to do that because we have all these exact values already determined on the unit circle. 30, 45, 60, and then remember that just gets kind of like transferred over to the other quadrants, and the signs are changed a little bit. You got some instructions on this unit circle about what's positive and negative, and anyway, you can see the addresses for all these points there given in positives and negatives. Okay, we're going to play a new game though this time. This time I'm going to give you, I'm going to say, what angle are we at when the cosine value is 1/2? I'm going to say something like that. And so I'm going to give you 2 bits of information. I'm going to give you which trig ratio, and I'm going to give you which value, and then you're going to match that up with which angle that's associated with. Okay? I'm going to give you, is it sine or cosine? And then I'm going to give you the value, and then you're going to look around and you're going to find that one, and you're going to tell me what angle we're at. Okay, so we're kind of playing the game backwards here. All right, so here we go. We're going to say, what is the angle when cosine is square root of 3/2? Or cosine is 1? Or the sine is negative square root of 2/2, or I'll give you another one, when the sine is 0. So again, what am I looking for? I'm looking for an angle. And you can give this in degrees or radians or both. So might want to write those down and hit pause, and then see if you can find them on the unit circle. And then write those answers down. Just tell you right now, some of these answers, there's more than one answer. It's hard to hold a smile for that long. Okay. Okay, cosine is square root of 3/2. Okay, well, cosine are the x values. Square root of 3/2. There's one right there at 30 degrees or pi on 6. 30 degrees or pi over 6. But wait, I found another one right down here. It's cosine, because it's the first address, and it's square root of 3/2. So it's also at 330 degrees or 11 pi over 6. That's interesting. There are 2 values where that's true. Okay, where's cosine 1? Cosine is the x address. I only see one place. Well, kind of technically 2. At 0 degrees or 360 degrees. That would be 0 radians or 2 pi radians. That's true. Now, the sine is negative square root of 2/2. That's looking for the y address. And I see that down here. And I see it in 2 places. I see it at 225 degrees and at 315 degrees. 225 or 315, which is equivalent to 5 pi on 4 or 7 pi on 4. Okay, so you see how we're playing this game? We're finding the angles when we're given the value of the ratio, of the trig ratio. Last one, where is sine 0? Well, sine goes with y. You're just thinking on a circle, we would find where it's 0, and that would be right here along the x-axis. So either at 0 degrees or at 180 degrees, which is equivalent to 0 radians or pi radians. That's where that's true. So what we just did there, of me giving you the ratio and the value, and you turning around and giving me the angle, we just did inverse trig functions. Okay? We just did inverse trig functions. What we've been doing is this. I tell you what value. Well, no, this is what. Yeah, this is what we usually do. I say, what's the sine of 45 degrees? And you go, square root 2 over 2. And I say, what is the cosine of 135 degrees? And you say negative square root of 2 over 2. And I say, what is the sine of 90? And you go, that's 1. Or you're giving me the values for those things. You're giving me the ratios of the sides of the triangles at those places. But what we're doing is the reverse of that. We're trying to solve not for the value equals A. We want it to be equals theta. And the way that we do that is we're going to undo taking the sine of that angle by taking the inverse sine of the angle. And that means we're going to have to take the inverse sine of the value. This and this right here are going to cancel each other out. It's like multiplying and dividing, basically. Similar to that, at least. And that'll give us the equation theta is inverse sine of A. And A being the value like 1/2 or square root of 3 over 2 or negative square root of 2 over 2 or something like that. Okay, so this time our input is a value into a sine or cosine function, an inverse sine or cosine function, and out spits angles. Sometimes one angle, sometimes two angles will pop out from off of the unit circle. So we're just playing that game backwards. We just did inverse trig functions, okay? So, yeah. There you go. This is what we're doing. And we would do something like this again. Let's put in 1/2, and then you'd say, well, the angle that's true, where the sine's value is 1/2, would be at 30 degrees or at 150 degrees. Or you could say pi on 6 or 5 pi on 6. You'd have to say both of them. And if they say for all real numbers, and say what are all the values, you got to add a little thing onto here. You have to say plus 2 pi n. And that just means if you rotate around the circle again, you'd end up right back at that place. Graphically, you're going to watch the other video that I've linked to you in the email on my other lesson from pre-calc, but it's the same thing, but it's very visual to show you why, what the graph of this function will look like and what it's doing. Now I'm not going to get into a whole lot of that, but I do need you to look at what's in your book on page 477 about what we call restricted domains. Restricted domains. If you recall, the thing that you plug into a formula is the domain. And the value that comes out of it is the range. Now, what we got here is a problem, because I just said that we're going to get two different answers for this problem. And then we could go around the circle an infinite number of times and get lots and lots and lots of more. So what we want to do with our game today is we want to say, well, I only want there to be one answer when I plug this into my calculator. In fact, your calculator will only give you the first thing here. Now, I have my calculator set to radians here. So it's going to give me a pi on 6 type of answer. But the inverse functions are right above the sine, cosine, and tangent. So you're going to use your blue button to get inverse sine, and then you can give it the fraction 1/2. Oops. There we go. Okay? That's what we got. And when we hit enter, it gives me a pretty messy decimal, but I've got this. Do you guys have this? I think I gave this to you. And I see that that's equal to pi on 6.5236, so I know that's what I'm looking at. I know what it is anyway, but there you go. If I go back and I set my mode back to degrees, and I do the exact same problem, then it's going to say, that's 30 degrees. And you're like, oh yeah, it is 30 degrees. But it only gives you one answer, okay? It only gives you one answer. So there's going to be some restrictions placed on where on our unit circle that we're going to be looking for answers. If it was not restricted, then you'd have to look for two answers every time you go around the circle once. We only want one answer. Okay, so the problem is with that, and the reason why we only want one answer is that the inverse of a trig function is not really a function that you can graph in the normal type of way.
That is why ugly.
Yeah. This is how the values for the sine function works in the real world. It vacillates, it fluctuates, oscillates between the values of 1 and -1 as you go around the circle. For instance, at 90 degrees, its value is 1. At 180 degrees, its value is 0. At 270 degrees, its value is -1. And at 360 degrees, it's back to 0. Somewhere in here is 1/2 at 30 degrees. And then it's square root of 2 over 2, and then it's square root of 3 over 2 at 60 degrees. And so this kind of gives you a picture of what that would look like as you're going around the unit circle and you're just tracing out its value. Okay? Now, what would the inverse of that look like? Well, the inverses of things is when you flip it over that line right there. So it's going to look something like that. Its inverse is going to be this piece right here. And if we kept going with it, it would actually do something like this. And maybe you can see why this might cause a problem. Because it violates the vertical line test. Right? If I cut through this, I'd say, oh, I get multiple answers when I plug in one angle. Right? This way is like angles are increasing. This way is just saying what the value of sine is. So what we do is we restrict it to a section of this whole curve that doesn't loop back on itself. We say, well, we're only going to let ourselves look between here and here. This is why on 277 through 477, they shade in different parts of the unit circle. And they say, okay, look, people, for inverse sines, we're only going to look over here. We're going to look in quadrant 1 for answers, or we're going to look in quadrant, well, technically I would need to say it as -1. You might think of it as quadrant 4, but instead of saying 330 degrees, we're going to say -30 degrees. That would correspond to this picture right here, where this is the only way that I can cut that inverse equation up so that it doesn't overlap it on itself. Very important. We can only look for answers for inverse sines in quadrant 1 and quadrant 2. If we looked in quadrant 2, we get another answer that's just like in quadrant 1, because sines are like elevation wise. They're in the y direction. So we're like, we get an answer here, and we'd also get an answer there, and they would have the same answer. That's the problem we come up against when we do the law of sines. We'll have two answers. We only want one answer. So we say, no, we're not going to look at that one over there. We're only going to look at the one answer that's over here. Like, for instance, you want to say, what's the sine of 60 degrees? You're going to say square root of 3 over 2. But if I say, what is sine's angle when its value is square root of 3 over 2? You'd have to say it's 60 degrees and it's 120 degrees. And we're like, no, just give me one of them. Okay, well, I'll give you the first one that it finds. This also gives it a chance to find a negative value, like if you said, what is sine's value when we're at -1/2? Okay, well, then you've got your 330 degrees, or you'd probably say -30 degrees would be the most correctest answer. That corresponds to somewhere over here on this inverse function like as a graph. Okay, so that's what sine's restrictions look like. Cosine's restrictions, I'll put cosine -1, sine -1. Cosine's restricted to the top half of the circle because values over here in quadrant 1 are all positive values, and over here in quadrant 2 they're all negative values. So it gives you one quadrant for positives and one quadrant for negatives. And if we went down here, we would find an x value that would match with 1 up in quadrant 1, but it'd be down here. So we only want one set of positive answers, one set of negative answers. Our calculator is only going to give us values between 0 degrees and 180, or between 0 radians and pi radians. Okay. Cosine looks like this. When you graph it, here's 360 degrees, and its inverse is like this. It's hard to draw. Its inverse is this snaky little thing here that goes between 0 and 180 degrees on that side. Okay, that's sine, that's cosine, and then tangents, restrictions. Well, tangents like slopes, so you get everything in quadrant 1 that's a positive and everything in quadrant 2 that's a negative. So for tangents, you're allowed to look here and here. But you get duplicates down here because you get positive slopes like in quadrant 1, and over here in quadrant 4 you get negative slopes, which is like in quadrant 2. So you're really only allowed to look between 0 and pi radians, or 0 degrees and 180 degrees for answers. And your calculator knows that too. It'll only spit out answers from quadrant 1 or quadrant 2 for you. Let me just double check on what your calculator will do here. Let's say that I go for inverse sine of -1/2. Yeah. You see how it gives me a -30 degrees rather than 330 degrees? So that's the way that your calculator is going to think of it too, as the -1 quadrant instead of quadrant 4. You can go down to that quadrant and say, well, that's 330 degrees, which is 30 degrees less than 360, and then kind of like that, there's your answer. So you need to pay attention to those restrictions. They've got a whole set of domain and range business there that you need to pay attention to. It would probably be a good idea for you to copy that chart in the middle of 477 into your notes. All that's a little heady. What really you're going to want to get to, and hang on, let me look up something. Yeah, sorry, I was just looking at how far I wanted to go with this. Since we're only covering examples 1 and 2 today, I'm about ready to shut this thing down. So my suggestion, have your unit circle handy, and just remember that if the restrictions are about quadrant 4 down here, that instead of using 330 degrees, you're going to use -30 degrees. If you're looking at the value at 315 degrees, you're going to say -45. Or if you're supposed to do these in radians, you're going to have to say something like -pi/6, or -pi/4, or -pi/3. Okay? If you've got questions, then let's have a chat. You guys have lots of options to you. Take those options, please. We'll again, I'll have a chat today. I'll have a chat tomorrow. You should get in on that. If you're doing other things like work when I'm working, you're not taking advantage of your options. And so if you're doing poorly, then you need to find a way of getting some help. I have a name tag here. It says, "My name is Help," and I'm not joking. I'm not joking. All right, I'm gonna tune out. You got some work from the reteaching. I'm sending that out to you. I think if you picked it up, that's great. Otherwise, I'm gonna have to email it to you maybe again. Get your work done, and we'll be seeing you soon. Probably not, huh? All right. Talk to you later.